Hello friends, next we are going to continue the methods of setting out of curve. Till now we have seen about the what are the elements of the curve and how we can determine the dimension of those curves in the previous videos. In this video we try to set out the curve by different methodology. Methods of setting out of single circular curve, it's of two way, one by linear method and another by angular method. Linear method, that is tape, chain, pegs that we can use. Angular method, we can use theodolite or tachyometer such that we can use the angle, right? First we see the linear method. In the linear method we are having four different methods classification. First one is by offset or ordinate from the long chord, by successive bisection of arcs or chords, by offset from tangent. This offset from tangent can be done by radial offset and perpendicular offset from the tangent, and by offset from the chord produced. These are the methods can be done to set out the curves, right? We will see one by one. First one, by offset or ordinate from the long chord. I try to explain with the figure. See, this is the curve to be set out. How to set, we don't know, but with the help of the intersection band we can place the theodolite, and the angle of intersection and the deflection angle you can place the tangents, right? So the tangent distance you can calculate based on the radius of the curve and the degree of the curve and the deflection angle, right? So then you can fix the point T1 and T2. So now you are able to get the distance T1, T2, that is the long chord length. From the reference long chord, how I can set these offset, each and every offset. If I am able to set these offset, if I join those points, I will get the curve, right? That is the ultimate aim. Since it is a simple circular curve, the mid of the curve is the mid ordinate. So one half, if you are able to determine the offsets, the second half is the same, right? So we already know the capital L represents the total length of the long chord. We are going to consider the half of the length, so L by 2 portion only we are going to consider. And at what distance we are going to fix the offset. So for that we are keeping E as the midpoint of the long chord. From the E, X distance, whatever the X may be 1 meter, 2 meter, 3 meter, 20 meter, whatever the distance based on the long chord length. For the X meter, what will be the offset? That is O suffix X. This has to be determined up to which the offset going to touch the curve, or we are going to join those points and to get the curve, right? So ultimate aim is we need to determine this OX, and you know this is the mid ordinate, so O suffix O naught. Already we are having the formula for it, but with the help of this we are going to determine this OX for the X distance. If the X varies, for this much distance the offset is this, for this much distance this is the offset, for this distance, for L by 2 distance, say it must be exactly 0, right? So that is the concept we are going to use it. So the what I have said, the terms we are showing here, right? In that we are simply consider T1 and T2 are the point of commencement and the point of tangency, and the I is the point of intersection and deflection angle, and the tangent distance you can get, and O is the origin of the curve and R is the radius. Say for example we need to determine this OX, we have denoted by this point as P and this point as P dash, and it is from X distance from the M. many reference books they use the notations are different. In the previous slide we have seen it is E, now here it is M. So you try to understand the concept, right? So at x distance the p dash is the offset to be set out. So the offset means it is exactly 90 degree. So the OX has to be determined. For that we need to draw a line P dash G parallel to TTE1, parallel to the long chord, such a way that it exactly make the 90 degree to the mid-ordinate. So the center of the curve is C, so the CM represents the mid-ordinate, right? So how we can determine these things? You remember this diagram, we will see one by one. From the triangle OMT1, what is OMT1? See, OMT1, we required the OM, right? OM is equal to OT1 square minus MT1 square, the whole square root. So it is a right angle triangle. So this minus this, so the R square minus T1M square, which gives the OM square, right? So that is the thing, and OM is equal to root of R square minus, what is T1M is the length of the long chord is L, half is L by 2. We have substituted L by 2 the whole square. Now we have obtained OM. Our aim, we required PP dash, that is GM is required, right? To determine that GM we are doing the initial stage steps, right? Next we need to determine CM, that is the mid-ordinate, which is equal to OC minus OM. What is OC? OC is total minus OM. The OC represents the radius of the curve, and OM we have previously determined, right? OM, that value you can substitute R minus root of R square minus L by 2 the whole square. That is the mid-ordinate formula for the curve. In triangle OP dash G, in the triangle OP dash G, right? So we required OG. We required OG. If you are able to obtain OG, already we are now with OM. We subtract OM from OG, you will get this distance GM, which is equal to that OX, right? So our ultimate aim is OX can be determined. So OG is equal to root of R square minus X square, and OM is equal to R minus O naught, right? R minus O naught is OM. So PP dash is equal to OG minus OM. OG is R square minus square root minus R minus O naught. So O suffix X offset from for the X distance from the midpoint of the long chord, which is equal to root of R square minus X square minus R minus O naught. This is the exact expression. This has to be used for the calculation in the problem, or even in setting out the in the ground, right? For approximation, say this root can be written as R square minus X square the power half, and R can be taken out common, so that 1 minus X square by R square the whole 1 by half minus R plus O naught, right? So this is the expression, say 1 minus X square the whole power 1 by half. If we expand that expression, you get R into 1 minus X square by 2 R square plus x cube by 2r cube, like that it is keep on going. Say compared to the radius of the curve, the x is very small, right? So and if you so this value itself very small, and the remaining, if you the r power cube 4 5, if you keep on going, those values become very minute, so we can neglect. So if you multiply the r inside, r minus x square by 2r will be there, plus o naught, right? So the r minus r will get cancelled, so remaining will be o naught minus x square by 2r. This is the approximate equation. You can, that is mid ordinate minus x square by 2r, that is x is the distance we are facing. 1 meter means 1 by 2r, right? Whether at the L by 2 distance, whether it will get 0, let's check. X distance is L by 2, the whole square, L square by 4. Here O naught, see, if you substitute this thing here, the everything get cancelled and OX become 0. I hope you understand this method. We will see one by one method in the next videos, right? Thank you, friends.